Good morning, good afternoon, or good evening for all of us, including the panelists and also for the attendees that present here for the ICACSIS 2020 12th International Conference on Advanced Computer Science and Information Systems. And for today, I hope that you are all being in a good health and condition because in this pandemic situation, we hope that everything is going to be alright. Okay, and for this special occasion, I will present my paper about tourism object detection around Monumen Nasional or Monas using YOLO and RetinaNet. And the contributors are me, Median Hardiv Nugraha, and Mrs. Dina Cahyati from University of Indonesia. And for today outline will be introduction consists of background, problem statement, motivation, and also methodology and results consist of comparison, analysis, and recommendation. And also there will be a conclusion. Okay, for the introduction is actually, tourism has become one of the most impactful sectors to a state's income, especially Indonesia. Indonesia's tourism has contributed to multiplier effect of Indonesia's economy, and also that multiplier effects causes the tourist and infrastructure expenses rise to many other sectors, such as an increase in the number of workers and overall income. Even though the economic contribution to state's income is relatively high, but the facility and infrastructure development in Indonesia for tourists are relatively low, especially in information technology. In spite, people in Indonesia are using IT to fulfill their basic needs by utilizing smartphone. There are actually 139 million internet users in 2015 in Indonesia only. By referring Indonesia's population census in 2015, there are 255 million population, which means there are more than 54% ratio of active internet users in Indonesia. By referring to this data, we need to implement IT to tourism sector, and one of the ideas is by using smartphone. Smart tourism is the answer for the IT implementation in tourism sector. Smart tourism has become one of the solutions to increase the tourism sector in Indonesia by using IT as a tool to enhance state's income. By the increasing tourists, the work labor will be increased as well, and it will enhance the economy of that tourism area. The best solution for effectively implement smart tourism in Indonesia is using smartphones. With smartphones, we can do almost every daily activity. By using smartphone technology, we can maximize the output of the implementation of IT to tourism sector. And the concept of smart tourism using a mobile application from the grand project of Mr. Ivan Fanani's Higher Education Excellence Research, which means PT-UPT or PT-UPT, which is Penelitian Terapan Unggulan Perguruan Tinggi. And also, this study has bigger research involving the PT-UPT, and for this paper, I will be focused on tourism side, which is the Monumen Nasional only. And then for the problem statement for this research are number one is how to utilize YOLO and RetinaNet to create a system that can recognize tourism site around Monas. And second is how good is the accuracy obtained using YOLO and RetinaNet, and how do the performance comparisons of the two visually. And from here we can see that the image the image is an example of a data set of Monas, which has been boxed with a green box. And then for the motivation of this research are to detect objects in the dataset based on the given class category, and then produce a model to be used on a smartphone, and to look and determine the best model of the both networks. So basically we want to compare both networks, and then we want to see which networks perform best. And then for the methodology stages are, number one is pre-processing. For the pre-processing, there are dataset checking, and then dataset augmentation, and then label converting. And then the next stage is model training, and then the last is evaluation. And then I will explain about the pre-processing stages. And this is the first stage of the pre-processing stages is dataset checking. We checked the dataset and we see that there are 37 classes, and from the paper we can see that there are some redundancy among the classes, and then there are some weirdness about the dataset and classes. So we clean the class, and then we finalize to 25 classes. And then second is dataset augmentation. By using augmentation technique, we hope that the accuracy will be increased, and then also the performance will be much better because we only have 600 images. And we use 17 different augmentation functions which are stated in the paper as well. And then for the last pre-processing stages is label converting, which is converting from XML, which is the original dataset format, and then we convert it to TXT by YOLO standard, and then to CSV by RetinaNet standard. And then from here we can see that there are two images that have been augmented, and the functions are median blurring and salt and pepper noise. These are just two examples of the 17 total of augmentation functions that we use. And then for the research design, we use 540 training images and 60 testing images, with the total of 600 original dataset images. And then for the augmented dataset, by calculating to 17 different functions, and then we have 9,180 training images and 1,020 testing images as well, by the total of 10,200 images. And then for the result, as we can see here, the comparison between the MAP value for YOLO and RetinaNet. We can see the bigger picture here that the original YOLO network has the MAP score of 71.99%, and then the augmented score is 93.72%, and then the RetinaNet original dataset is 92%, and then the augmented is around 55%. And then we can see here for the comparison of the false positive rate and true positive rate of the YOLO network, which is, as we can see, that the true positive rate of the original dataset is 1 at threshold 0.1 and 0.2, and then for the augmented, the threshold score in 0.2 of the TPR score is 0.937. And then for the analysis of the result that previously described. And then we can see that the RetinaNet network perform not really well because we use a different techniques to you we use different techniques to with the hyperparameter configuration, and the RetinaNet used a smaller amount of epoch number, batch size, subdivision, and steps comparing to YOLO because we want to use the default configuration from both networks. So we don't want to have a kind of interference between the original or the default configuration. But maybe we want to see that the RetinaNet networks may have a better performance if we do more epoch steps. And then we can see here for the loss function of the RetinaNet original and augmented data, the loss function is decreased stagnantly, and maybe there will be no more decrease of the loss function. So we can see that the performance of the RetinaNet networks may be at its best. And then the recommendation for the next research of this paper will be increase the number of dataset, which is the more images that we can train, the better result that we can get, because basically the number of images containing monas object has more accuracy compared to the other objects, and then we want to have a better accuracy for other objects as well. And then secondly, we want to do a cross validation, because by using the cross validation we can the cross validation can help enhance the performance by doing training and evaluating multiple times with the same dataset, and then this method may work better with less data. And then thirdly is use hyperparameter tuning, and we can see which configuration performs best and apply it to the model training. By searching the ideal hyperparameter configuration, we will know what kind of configuration best perform with certain network. And then lastly, the fourth one is improve each networks. By improving each network, we can see the performance enhancement and decide which network is better. And then a conclusion for the paper is, by overall performance, YOLO has the best performance by comparing the MAP scores. And then RetinaNet has the best performance and detection stability based on the score of threshold range. Okay, then that's all from us, and thank you very much for your attention. And the Q&A session will be open soon. Thank you very much.